Okay, this question talks about a AC voltage source or EMF given by the equation 170 times sine of 377t. It is connected to a 100 ohm resistor. And so in this question, the 170 here represents V peak, and the 377 represents omega, which is 2 pi times F, which is the angular velocity of the generator. And so let us think about the fact that that source is connected to a resistor, and the resistor has a value of 100 ohms. So we can draw this circuit. Now, with respect to our description of the source here, we can say that this voltage equation applies. However, for part A of the question, we are asked for V RMS, and it is equal to the peak value divided by the square root of 2, which says 0.707 times the peak value. So V RMS is equal to 0.707 multiplied by 170 volts, and that gives us approximately 120 volts RMS. So our voltage source over here then, 120 volts. Now part B asks us for the RMS current in the resistor. By Ohm's law, I equals V divided by R. We have 120 volts RMS divided by 100 ohms, says that the RMS current in the resistor then 1.2 amps. Part C, average and RMS power delivered. And so the RMS power would be V RMS multiplied by I RMS, and we have 120 volts multiplied by 1.2 amps. P RMS then at 144 watts. Now, the average power in the resistor should be equal to the peak or maximum power divided by 2. And that means we can take V maximum or V peak, multiply that by I maximum or I peak, and divide by 2. And so remember, I guess, that we're going to say that, now there's more than one way to do this, but we can say that I peak equals V peak over R. And so that saves us from calculating I peak, which of course we could do. But we can say then that this is V peak over 2 multiplied by V peak over R, or V peak squared over 2R. And what we're getting at now is that we can calculate the average power without having to calculate the peak value of current. And so we have, remember, the maximum value or the peak value of the voltage was 170 volts. If we square that and divide by 2 times 100 ohms, or 2R, if you do the math there, you come up with 144 watts as P average. Now, this question has been designed to show that the average power in the resistor and the RMS power in the resistor are equal, and that has to do with the way that the power waveform is shaped, because remember that if the voltage is 170 times the sine of 377t, and the current waveform is equal to 170 divided by R times sine of 377t, then the power in the resistor as a waveform would be V times I, or 170 times 1.7, and if I multiply the sine 377t by sine 377t, then I get sine squared 377t. The shape of the sine squared waveform basically says that the RMS value and the average value of it will turn out to be equal. And I guess then that remember the peak value here, we said that the average value was the maximum value divided by 2, and so I assume that if you multiply the 170 by 1.7, you come up with 288 times sine squared of 377t as the power waveform.